Hey everyone, my name's Kyle, also known as Tech Squid TV, talking to you live on all the platforms with Depot.dev and the creator of the Yoke CLI, a new type of package manager for Kubernetes that uses infrastructure as code principles so that we can get rid of YAML and start using actual code. I'm going to bring David up on the stage and allow David to introduce himself. Welcome, David. Thank you for joining me today.
Hey, Kyle, thanks for having me. It's actually my first live stream ever, so I'm very stoked to be here.
Glad to have you.
Yeah. As you said, my name's David. I wrote the Yoke CLI, which is my personal response to the Kubernetes package management as it is. Yeah, I've been a backend developer for about 8 years now. And then we've recently, for the last year, have turned my attention to DevOps, or what's now called platform engineering, and trying to make it feel a little bit more like back engineering. We'll see how that turns out.
I'm very excited about it. For those who wouldn't know, because no one would, David and I actually worked together at our previous jobs together, and we were super involved, always chatting about open source projects. And specifically, we talked a lot about replacing YAML with code. That was one of the things we were doing at our last jobs, totally unrelated to this, but I see you've taken it and kept going with it into the Kubernetes world. So let's start off. I would love to do a little bit of an intro into what Yoke is and how folks can use the CLI, why would they use it, and then we'll pedal back a little bit and we'll start discussing a little bit about infrastructure as code, YAML, and then we'll do a demo towards the end. So if it's all right with you, David, I'm going to share your screen and then we will switch over to your docs page. I'm going to give you an opportunity to let the people know what the CLI is, how it works, and what it does.
Yeah, sweet. Let's do it.
All right, I'm going to give you the screen, and there we are. All right, so we are on your documentation site hosted on GitHub Pages, and can we actually, do you have the GitHub repo open as well? Maybe we can give folks a link to the, oh, it's right there in the go install.
Link over here.
Perfect.
Here's the go install. Yeah, I haven't gone to the point of making it available on Brew or other package managers. It's still a very Go-centric project, so hopefully that's fine. But when we're working with Kubernetes, it is Go-focused in general. So yeah, the repo is here. You can find it, David MDM Yoke. And
we will have it in the show notes, of course, as well.
Absolutely. Yeah, so I'll start by just saying a few words about the project. It's still a very youthful project. It hasn't been around. It's only been around for about 6 to 8 months now. It's still pre-version 1. And I would love if it took off, but I would also love if it inspired new trains of thought on package management and then how we use Kubernetes and how we glue things together. The idea is that it's like Helm or Timoni, if you know it, right?
I don't know Timoni.
Timoni is a very cool alternative to Helm. It's another package manager. It used really in the Flux ecosystem. And instead of using YAML, it uses Q.
Oh, yes. Okay.
Right. Which is a super cool venture. And I actually am a huge fan of Q. I'm somewhat active in the Q community as well. But for me, what happens is that, we upgrade from YAML, right, where we define everything in YAML to defining it in this other language, which does have typings. But when it comes to expressing, logic and control flow, to me, it always feels like IaC is the way to go. And so I wanted to experiment, and I created the Yoke program, which is just another package manager. If we look at the CLI reference, we can see, it's a Helm-inspired package deployer. And we can take off, descent, Mayday. We have
I love the terms in there. I love them all. If you can't see the theme yet, folks, what is the theme?
Well, the theme is that a helm is the steering wheel of a ship, right? And Kubernetes was and is, I guess, a ship, a Greek ship. And so here I'm trying to say, well, we can evolve a little bit. We can take a different direction. And the yoke is the steering equipment of a plane. So we're going from a nautical theme to an aerospace theme.
I love it.
But yeah, trying to keep in the in the same concept. So here we have these available commands, which are just the normal commands: up, apply, down, restore, delete, things like that, of that nature. And what it allows you to do is do exactly what you would do if you imagine this being, Helm, install, your release, and then your chart. It's very, very, very much the same, except that you use different terminology. You usually say yoke, takeoff or up, your release name, and then the path to the flight. So where Helm had a chart, yoke has a flight, keeping in that theme, right? And what a flight is, it's just a program, a general purpose program that outputs, that will output your package, all the resources that you want, which is exactly what a chart is, except a chart is a bunch of templates that will output your package. And so you can create your resources and your packages as code. And usually the way that we create this code and use this code is to have it be WASM. Because in WASM, we solve a lot of problems, and we can get to that. I don't want to say too much and bore anyone. We'll get to that. But the main idea is that where Helm uses YAML, Timoni uses Q, and Yoke uses WASM.
And you can use any programming language to, well, not roughly most programming languages to get to WASM, right?
Exactly. So any language that compiles to WASM, and they all do more or less. I mean, they don't all have like equivalent support for it. But those that do and that can support WASI Preview 1 can be used, right? So obviously you could use Rust, you could use Go, you could use Zig. I'm sure you could use
all the fancy languages.
If you use the fancy languages, I know that there are like Python compilers to WASM and JavaScript compilers to WASM.
There's a TypeScript adjacent language out there. I haven't played too much with it at all, but yeah, it exists.
Assembly script?
What was it?
Assembly script?
Yeah, that's right. That's correct. Yes.
Yeah. And I mean, the recommendation of Yoke is to use WASM. There are benefits to using WASM. But technically, you don't even really need to. You could, there are examples of this. You can omit the WASM asset and just, pipe whatever resources you want in. So you could say yoke takeoff my release, and just put in some resources. And because the point is that the package manager and how it evaluates packages is slightly separate, right? You can just give it the resources without telling it to run a program and just say, please manage these resources. So you can do that. Or if you want to do it from a Unix pipe, which would be the same thing as saying, well, I want to write it in, say, Ruby, and let's say Ruby doesn't have great WASM compilation. I don't know if that's true or not. Let's just pretend that's true. Then you might say, well, I want to write my package in Ruby or in JavaScript, but I can't or don't want to compile it to WASM. So I'm just going to write my package and I'll pipe it to Yoke, and Yoke can deal with it and create a revision for that output and manage it.
That's great. So the idea would be, just to reiterate for the simpletons among us, me being a Node.js developer, and as we discussed, getting into WASM from Node is quite complicated, but we can generate JSON very easily from objects. We can create our types and TypeScript and such. So if we can output that JSON, then we can just pipe that directly in and skip the WASM part of this equation.
Absolutely.
That's fantastic.
Yeah. And I see that I have a typo right here.
Always when it's live. That's when you really see it.
Yeah. Before it would have been invisible, but.
Well, here, let's see. I don't know if there's no view count in front of me, but oh yeah, there we go. Small view count, but it's open source, folks. So it would be great if by the end of this stream, that was no longer the case. Go submit a PR. We'll be here. If that PR is in, we'll do it live.
Awesome.
All right, great. All right, so thank you for explaining all that. Do you want to? I'll let you take us where you want to go next, but I would love to see an example of maybe a flight, or if you, I know when we were speaking earlier, you did a demo of how it can work direct. Oh no, my doorbell is ringing. I don't think that's something you can unplug. So if you can give us a look at maybe some source code, that would be fantastic. And actually, you can save me, and I will go grab that door real quick.
All right, sure.
So what I'm going to do is I'm going to give you the full screen right here. Great. And give me one moment. I'll be right back.
Yeah, awesome. Well, we might as well. Okay, I can show examples of what this would look like. Here's the Yoke project, right? The actual GitHub to the Yoke project. And in the command folder, we have examples. And the simplest example is right here, which is a program, right? This is the equivalent of writing a chart. Instead of writing a chart where you start to write, a bunch of templates and Go templates and interpolate values, you're actually going to write code, and this is the code that we're going to run or compile to WASM to have it be evaluated by Yoke. So here, what we're doing is we're actually taking advantage of the Kubernetes packages, the ecosystem that already exists, to already have the types and the builders to build Kubernetes objects. And this program is just a Go program. For those that don't know Go, I hope you can follow along. It's just the main entry point. We run the main function, which will be called run. And here we're just building a deployment, right? We're saying apps v1, deployment with labels, with spec. The indentation is funny because it's Go and it's GitHub. So it uses tabs. But we're building this deployment. We're giving it labels. We're giving it a spec. We're giving it values. And at the end, we're returning, we're actually encoding this value as JSON to standard out. And that's the way that we communicate with the Yoke CLI, is by having these programs write to standard out, and whatever's written will be applied. So in this case, we're creating this deployment, which is just an image of Alpine that's saying hello world in a loop. So this would be an example of writing a flight, and then we would compile it and use it. And we'll have an example of doing that with a more interesting program a little bit later.
I was just going to say, and maybe let me know, we can do this in a minute too, but I think it might be a little bit more obvious to us, but to someone who's watching right now, I imagine they might be thinking, well, that's just YAML with more steps.
Yeah. Well, it is YAML with more steps. But okay, but let's take a minute then to talk about why we would do something like this, right? There's always the answer of because I can, right? Which some people adhere to. But the reason is, let's take another example. Let's stop talking about Kubernetes for a second. You said that you were a Node.js developer.
Yeah.
Right? Do you use JavaScript or TypeScript, generally speaking?
Only TypeScript. I can't even imagine going back.
and why do you use TypeScript?
Good question. First of all, I like having a strongly typed language, but I actually use it for a lot of the developer experience of using type hints is a lot of my reasoning.
Yeah. And I think that's essentially why we would do it like this. I think that, the reason that the world went from, 2015, everyone was using Node.js, JavaScript, and then by 2018, everybody was using TypeScript, is because what's the job of a software developer? The job of a software developer is to glue a lot of contracts together. Whether those contracts exist at the function level, or whether they exist between services, or whether they exist between, the user and the back end, or whatever, it's all about contracts. And if we don't use tools that help us enforce those contracts, then essentially all that coding is writing text documents and throwing them into the ether and hoping that it works out. And so that's why we build tools like TypeScript and other static languages, or we're seeing the resurgence of static languages, to really give us these developer experiences where we can have confidence in what we're doing, And also it allows us, through all these like tools that we have, like language servers, to explore our possibilities and figure out what we can do. And that's why we would go through the hassle of writing code to express our packages instead of just writing YAML.
Yeah, absolutely. It's so funny. We've both seen it with our histories, but something I see with YAML too often, and you'll see it with I don't know if there's a name for it, but like Ansible's version of YAML starts with a J.
I forget.
What a ginseng? I can't think of it. But all these different like YAML specs. I mean, even GitHub has their own YAML spec now. I kind of like theirs, but I'm a little biased as well. But the problem I have is people keep using YAML and finding these hard edges. They're saying like, I want to, and we could go into like what problem are they trying to solve when they're using YAML? Because I think they're trying to simplify something, but turn it into a, if it's a static configuration, going on a small side tangent, but if it's a static configuration, YAML makes sense. JSON makes sense if it's completely static.
Maybe. I think that it's kind of. Have you ever watched Community?
It's on my list. I haven't seen it.
They take place in a school and they're taking different classes.
That was it, Adam. Oh, we have Adam Whitlock in here. Thank you, Adam.
Oh,
Jinja 2 is what I want.
So here we are on a tech live stream, and we're talking about Community. There's this show, and it takes place in the community college, and one of the classes is psychology, or one of the, it's played by Oliver, the guy that does that late night show. Okay, it doesn't matter right now. The point is, they're taking a psychology class, and it's about like delayed gratification, right? Would you take the marshmallow now, or would you wait an hour and get two? And I think that's kind of what we're doing with YAML versus different alternatives.
Yeah, I like that.
Is we're saying, well, to do this, there's a few steps I have to have, right? I need to know I have to have the Go compiler. I need to know how to use it. I need to know how to write Go. There's like I need to set up a lot of boilerplate. Just here, I had to write my imports. I need to know what these packages are, which ones I'm going to use. I need to write the setup of a main. I need to have the error handling. I have to have exit codes. There's a lot of like little steps that you need to do before you get to actually write your package or your configuration. With YAML, you just skip all of that. But then you're faced with like other problems, like what am I writing, right? Like what are the expected keys? What's the expected type of those keys? What's the structure that I'm going to end up needing? Is there any constraints between them? Where's the documentation? Like you're just left to writing a text document.
You're just replacing a language. This is what I keep seeing happening. When you have a, it's like the actual standard YAML, what is it, 2.1 spec or whatever we're at right now, which is just JSON. Perfectly, you can just use any type of JSON language server to interpret that, and it's like I said, completely static. But once you start working with any of these other systems that use templates or introduce their own logic, now you need a new language server. A lot of these, which one I'm talking about, have implemented their own package managers. It's like at a certain point, why are you not using a language? And maybe it's because, and I think you had a good point there. Maybe it's because, we need to know that we have a Go developer. Or we need to know that we have a Node developer. And we think that we're getting away from that when we, switch over to something like YAML. But when we start getting into complex logic, and I'll use GitHub as an example because I do like what they have, but anyone who's written a GitHub action or a GitHub workflow has probably used some of the arguments in the you can do things like if this output is equal to this, then don't run the next step, right? These type of logical operators that really shouldn't exist in YAML. But now what you're saying, and what I think is really interesting, I'm going to bring up another company at some point here in a minute too, but it doesn't matter the language, right? Like all of these packages could be written in different languages. and they can all benefit from their own ecosystems, their own package managers, their own language servers and things like that. I can write my package in Node. You can write your package in Rust and Go, and we can still deploy no matter what, right?
Absolutely. I mean, the contract here, I think you're bringing it back to Yoke or to this system, is that the contract, and we talked about glue and stuff, the contract is that you just need to have a program that outputs your resources. And Helm is the same thing, right? It is a program, and it outputs your resources, right? If you run the Helm template command, that's what it'll do. It's just that the Helm is like a system for you of templates and using Go templating, and you need to learn its docs. You need to know, you need to know everything in your head, right? You need to know your values.yaml contract in your head. You need to know the Kubernetes contract in your head. I mean, okay, you have access to the internet, but you need to know all of these things or have access to this information, and you need to figure out how it works. Here I can, and we'll see this later when we actually start doing a demo that we've prepared. I can, control space and see all of these different builder functions and their documentation available to me.
Yeah, which is fantastic, which you can kind of do sometimes. So like in case someone's confused, you can kind of do that sometimes if you have like a JSON schema. Like there's a difference between a schema and a language server for maybe folks who don't know. A schema cannot account for anything that's not static, right? Like a schema relates to a strict static type system. A language server is able to evaluate certain properties or templates and things like that to get you a little bit more information. So sometimes you can get like type hints when you're working on some known schemas, but that's not the same as working with a defined type system, which first of all is ever evolving and auto updating. It's also auto documented. It's not a manual process at that point. It's something that comes built in.
Yeah. And it's also something that, it's the whole point of shifting things left or bringing things to compile time. I've had this is like an anecdote of one of my workplaces where, we were running Argo CD. And to run Argo CD, it's a continuous deployment system that takes like webhooks from your VCS source. So if you change something to a repo that contains certain resources, it'll send a hook to Argo CD and it'll, deploy what was in your VCS. But to do that, you need to set up the ingresses and all of that, right? So somebody went in and refactored the Argo CD. It was deployed as a Helm chart, and they, they untabbed or removed a level of indentation from all of the controllers, from all of the ingresses, I mean. And yeah, we didn't have any notifications. We didn't have any webhooks coming in for like a week. So everything was slow and nobody knew, right? And there was nothing to tell us that we had broken the contract.
That would be so hard to spot too.
It was hard to spot.
Yeah, I mean, yeah, and that's another fun thing with YAML for folks who don't know. I mean, we kind of talked about how there's already like lots of different flavors of YAML, of course, depending on, what template system you're working with and things like that. But even the base YAML 2.1, I think it is, spec, it's open source and there isn't like an official governing body. So a lot of people are probably already familiar with, there's two main different YAML engines. I don't remember their names, but one of them will treat true and false as I think a literal string true and false, and the other one will switch it to a 1 and 0. So if you take the same YAML file and process it through two different engines, which is something you might do if you're, using some kind of YAML package in your program, you will find these little differences and things like that in how they process certain data types.
There are some engines that treat the literal strings on and off as Booleans.
Oh, yes. Yeah, that's right.
And then, even like, I mean, we've had this at, can we say the name of our previous?
Yeah, we can say it. Yeah.
Okay, well, we both worked at Circle CI, which as a CI platform, you write a lot of YAML for. And internally, we were considering, between different services, the handling of these YAML documents. And, just working across multiple languages, you can see that like they don't have support for all the same YAML features, right? We had issues where, merge nodes weren't supported in Go in the same way that they were supported in like Java, right? So even when working across like different languages that should be compliant to the same YAML spec, not everything is supported, and so you end up getting like vendor locked into whatever language you're using to work with YAML. So there's a darker side to it than you might think.
I think it's kind of funny. And then after this, let's kick off our demo. But I think it's kind of
Absolutely, we're
funny.
just gonna like talk about it forever.
We can, and I'm here to bash YAML. That's my true passion.
Yeah.
But I find YAML to be such like a funny like oxymoron of a thing in general. Again, if you're using it for like purely static content that is truly static, okay. Like for instance, front matter
Yeah.
in Markdown makes perfect sense. For the most, like if you want to start doing dates and things, you're doing funny things. Again, once you start touching something that I think is no longer static, we get into this weird position where what is YAML supposed to be? It's an intermediary between different languages, but it's not. It's meant to be a easier method for like non-developers to configure things, but the only people that are using them are developers. And it's really just purely always, in my opinion, getting in the way. So I would love to just replace, and since we already mentioned it, folks may want to know, I guess. My most popular package on NPM by far, although I'm no longer attached to it, is when I was at Circle CI, who uses YAML as their config language. And they have their own flavor as well. So there are like conditional logic and things like that. But of course, their conditional logic is different from Ansible's, which is different from GitHub's. Everyone has their own flavor. So what we're talking about right here was one of the problems I wanted to solve. I think you did it more elegantly, differently. It's not the same thing, but more elegantly in the same. I just created a Node SDK so that people could write their Circle CI specific YAML with a programming language, much in the same way that we're talking about here, where you're writing Helm with a language, and in your case, any language, which is awesome. I was using Node to convert to this Circle CI thing. And what's also pretty great about that is it's hyperinflated because people use it in their CI. So it looks super impressive on NPM. It's got like 50,000 downloads per week or something like that because people are running it hundreds and hundreds of times per day. It's fantastic.
Boy, that's how you get your numbers up. That's
yeah. It was all part of the plan. All right, let's talk about let's kick off a demo. So what are we doing today?
Right. Well, we thought that we could deploy something in the Kubernetes, right?
Awesome.
And I'm going to demo Yoke, but also we're sponsored by Depot. You're an advocate for Depot, so we might as well, if we're going to switch out Helm with Yoke, we might as well switch out Docker with Depot.
Fantastic.
And we'll see how that goes.
We'll do a little explanation about Depot and replacing Docker when we get to it.
Yeah. Do you see my screen right now?
We do. Yep. It looks good.
Awesome.
Actually,
Great.
You want to make it like a smidge larger? It might get rid of some of the blur. Good enough. We're good.
Perfect. So what we have is a project called C4TS that you can translate in your brain to cats. And it's a little TypeScript file. And I'll just walk through it in a second. It just reads some images from the IMGS, the images directory. They are cat images because that's what we like.
It's the internet. We have to. It's by law.
It's by law. It's
Yeah.
by law. We read these cat images from that directory. We read them, obviously. We create a little node server. I didn't even use Express, just straight HTTP. And it'll just serve a random cat image. It'll get a cat image and it'll just write that image /JPEG and send over the cat.
So an essential service of the internet. One which I imagine everyone should deploy to their Kubernetes cluster, possibly again by law. I so just want to say real quick, hello to Chris Black. Haven't seen you in a while. What's going on, man? All right. going back in. Sorry to derail. Yeah, but I love our cat service. And this will be on GitHub later, maybe?
Yeah, I mean, it already is, but it's private. We could for sure in the show notes make it public and.
I just think people need access to cat servers. It's,
Oh.
you know,
I mean, they do power most of the internet. So we have this little server, and then we just start it. We wait for graceful cancellation, and we close our server once we
glorious.
close things. So that's basically production grade software in a nutshell. And we could run this locally. So if we say, I'm using Bun because why not be on the edge?
Why not?
And if we run this, we'll see that we're listening on port
Did you
3000, which is
say,
our default port.
tangent real quick again, Node is getting some version of natural TypeScript support. Not that it'll be as fast as Bun for like so many different reasons, but one more thing that Node is finally catching up on.
I'm excited for it. And you can see now that this cat server is serving.
That's my cat.
Yeah, these aren't. I mean, these are beautiful cats, but I didn't pull this from the internet. These are cats of people I know. This is my cat, your cat. It's random. My friend's cat.
So grumpy.
Yeah. So we're getting this one has sunglasses. So we're serving cats. There's not a million of them, so they'll circle back.
Yeah.
Quickly.
But we have an essential internet service and an API, if you will, loosely. Not really, but kind of.
Yeah, but we're still stuck completely in local development land, right? We're still running on localhost 3000. This is being served by the process that I threw out over here. We're not, we don't have any containerization. We don't have any packages. We don't have any Kubernetes at this point. So that would be the next thing to fix, right? So let's stop this program.
Getting it deployed in the modern world. We're not using FTP here, folks. There's no PHP servers, so let's do some modern things. Let's use Docker files. Fantastic.
Exactly. So over here, we should see my Docker file. We're using the official Bun version 1 image. We're using an app directory for good practice. We're copying over our dependencies, our package JSON, our bun lock, which is the same as a package lock, running bun install, copying the source over, declaring that we're using a port that will be by default on 3000. Our entry point is the bun program, which the bun from statement has for us. And by default, we're just going to run that source.main.ts.
Glorious. I've never run a Bun Docker container. I'm kind of curious how big the images are. I'm sure Bun is like one of those super efficient folks. So I'd be curious. I bet it's a really efficient image is what I'm getting at.
Yeah. So let's build this. This is the one time where I'm going to use depot. So if you want to talk about depot.
Yeah, let me go in here. So we're replacing basically. There's the Docker build command. I think most people in here are going to be pretty familiar with it. We're just replacing the word Docker with depot. We're also going to throw on another flag called load, and that'll be important in a second. I'll explain. But all depot does is it centralizes your build process into the cloud, AWS specifically, and it centralizes that cache. So if David and I were building the same image on both of our machines, he's building it now. If I was to try and build it again right here on my machine in a second, it would build instantaneously because we'd be accessing the same cache. And one of the real reasons why you would want to do that, I mean, that's great too. But if anyone here is familiar with the CI/CD process, if you've ever used GitHub Actions, Circle CI, GitLab, any of these things, most of the time when you're working with these services, they are ephemeral, right? You run some job, you build something, maybe you push it to a registry, but then the job closes. And typically with no extra configuration, you're going to lose access to that cache, which means every single time you're rebuilding from the start. You can manually save your cache, which means running like the Docker save command and then pushing it off to some blob storage, like there is GitHub's native cache actions. There's also like, S3 and things like that. However, that's still pretty slow, and you have to download that large image every single time you run up the job. So, sometimes that's a gig. Sometimes it totally depends on what you're doing, but it could be quite a lot. And one thing we really don't want to do in our CI jobs, I mean, we try to limit how much we're downloading at runtime, right? Because that's a potential for a flaky process to happen. You don't want your job to fail because it had to download something. So when we use Depot and centralize everything somewhere else, not only do we not have to worry about uploading and downloading cache, we don't have to worry about it at all. It's just all natively built in. Depot also has, I'll throw out there, GitHub Action runners as well. So you can actually just take your GitHub Action workflow as it is, run it inside Depot, and get access to the same cache. In fact, we actually wrap GitHub's native cache. So you don't have to change anything in your config. It just works. That's my spiel. Thanks for letting me do it.
Oh, awesome. And I'll just say that my company, where I currently work at, we're starting to experiment and use Depot ourselves because it has cut a lot of build time in our CI.
Yeah, that's, I mean, we like to, that's one thing. I mean, so just me personally speaking, kind of like off the, I mean, I'm repping Depot, but also just like something I really like about Depot and like these types of products and services, you can just do math to figure out how it saves you money. Like, this isn't a question of, is this going to work for me, or, you know, what's the value of this? It's not an ambiguous thing. You can just do math. Like, how much time does this, try it for a month, do math. It just saves money. It's great. It's just an automatic save money.
Right. So if we go back to the demo, let's just see if we do the Docker image ls, we can.
Yeah, how big is it?
It's 214.
Not bad. Yeah, that's pretty small. That's actually really small. I mean, it's not as small as like, you know, Alpine out of the box or anything, but I think that's about the same size as the Node Alpine. You want to pull Node Alpine real quick? I want to compare that now.
It's like,
I think it's LTS dash Alpine. Colon LTS dash Alpine.
colon LTS dash Alpine.
I think. Yeah, let's see. Yep, that was it. Okay, so just because we're curious now, how does Bun compare to, I mean, and your project is in here too, but that's very small.
No, my project isn't.
Oh, is that just the Bun?
I mean,
the cat's image.
Yeah, it could just be the cats that, you know, is blowing up the
yeah, it's barely anything.
Docker image ls. And we have,
dun dun dun. Where is it?
There
it is. 132 megabytes. Oh wow, that's a lot smaller than I thought it would be. So Bun is actually almost double the size. We could look into that. I mean, we also use, like, I wonder if there's an Alpine version of the Bun image too.
Yeah, we only have 6 megabytes of cat images, which is not a lot.
No, yeah. I'm gonna take a quick look, and now I'm curious. Alpine Bun image. Does that exist? It does. Yeah, there is a dash Alpine if you were trying to optimize even further.
Right. And anyway, so we built it, and we used Depot build load, and we tagged it as cat's latest. And now we have this Docker image that we've loaded into our machine built by Depot. And if we run it, we can run it on port 3000, similarly to how we had it running locally before. And if we go here, this should continue to work. We're continuing to serve cat images.
Backbone of the internet.
We are doing good. So if we come back here, now it becomes like, okay, well, we want to put this in Kubernetes.
Mm-hmm.
We can, from now we need to start writing a package. We could, you know, write raw YAML, but, you know, let's pretend that, you know, there's going to be a lot of things that we need. We might need, you know, a deployment. We might need an ingress. We might need a service. We might need a pod disruption budget. We might need like a lot of things. So we're not just going to write it in straight YAML. We're going to want to create some kind of package. And because this is the point of the demo, we're not going to write a Helm chart. We're going to write a program to express
Fantastic.
it.
Exciting.
For the sake of time, I did write a branch for it. And because I don't want to bore people, let's just check it out. Over here, we have the flight. And I wrote a program that we can compile down to WASM that's going to output the deployment that we want. So it's a little bit like that example that we saw before in the Yoke examples. We're using core types, right? We're using Kubernetes client Go, apply configurations. That's the builder package to build different resources. And we're using apps v1 because deployments are in apps v1 construct. And we're going to start building. So here we're using the flight package to get information like the release and the namespace that we're deploying to. Where, this is the shell for our main function. And if we look at run, in this case, run is just decoding to standard out this deployment, this create deployment. And if we look at the code of create deployment, it just returns this deployment apply configuration, which is the configuration for deployment. And we can see how we're going to build it, right? We're going to create some labels, a map of labels, app to that release. We're going to create a container. So we're saying core v1 container with name, with image, with pull policy, with ports. We're running out port 3000.
So you're building up each component of your chart is what it would typically be.
Exactly. And if I was to, if I wanted to continue and say, what are the other things that I have available to me, I can just pull this up, right? I can't get it wrong. I don't need to worry about, how to write this in my YAML. I can't say this is port 3000. This won't compile. I'm going to say that I cannot use an untyped string, right? We don't have all the problems that we have with YAML.
And you don't have to use, I suppose maybe you could correct me on that, but you don't have to use the typical like Helm templates anymore. Now you can have much more robust functions that actually return components based on inputs and arguments and things like that. And then you could even go on and test those functions and do anything you want within that scope of your language.
100%. And sharing these functions that create the resources, they don't have to be they don't have to be like in a central chart repository like Helm does. You can just create a package, publish it, and import it, and so you can share the components without having to create these like new types of registries of objects. So it's just code, right? You get to use all the package managers that and all the goodies that come with your language ecosystem.
Yeah, that was a similar thing I was doing, when I wrote my SDK, not to go too deep into that, but yeah, like just being able to use whatever you're already naturally familiar with immediately eliminates all of those blockages that, YAML, I guess theoretically is supposed to come in and solve. But if you can just say, hey, we need, this flight, this Helm chart, but we're in this case flight.
Yep.
Go write it. Whatever language you do, go do it properly. Put in all the best, architecture principles and things like that for your language on whatever package manager, registry, whatever system you want. Because we don't have to worry about all these hyper specific, like DSL type things. We can just work with what we have, which I don't know why anyone would fight that. It just seems like a great solution.
Absolutely. And you have control flow as like a first class citizen, right? You can write for loops, you can filter lists, you can compute, you can do you can do anything that you can do in like general purpose code. You're not limited to the little helpers that are provided by Helm, right? Or
right.
And you can build your code any which way you want, right? Which is great. So here, let's compile this program, right? So I'm saying to go to the Go build tool, the Go compiler that we're going to use it. We're going to compile this to WASM, and use the WASI preview 1. So we build this, and then we can say, I'm just going to start a kind instance.
And for folks like me, kind is a local. It's like a K3 alternative.
Yeah, it actually stands for, the K is Kubernetes in Docker.
Oh, okay. Very nice. Okay, that's interesting.
Yeah, so it's basically just running Kubernetes inside of Docker.
So very good for like doing demos and things like this.
Exactly.
Fantastic.
I don't need to pay Amazon to host a Kubernetes engine for me, which is good. So here, if I say yoke takeoff, we're going to call this cats. That's the name of our release, and pass in this main.wasm. And before we even actually take it off, we could just say test run, and this will print out. It'll evaluate it, and it'll print out what the program is actually giving me. So we encoded that to JSON. So let's just pass that to YQ-P. This is the actual use for YAML, is to pretty print what we're actually going to be deploying. And so what you see, I'm actually going to run it again so that it's a bit cleaner. Like this. So what you see is that once this program, this main.wasm, is evaluated, we're actually giving an array of resources. And you can see the kind is deployment, apps v1, the metadata is cats, namespace default, label app cats, replicas 3. And you can just, I'm not going to read it all out to you, but you can see exactly what got generated by this program. And that's one of the nice things about using WASM, is that because of this, we don't need to have, your runtime. We don't have access to the network. We don't have access. Like it's like a sandboxed environment that lets you have all the logic and generate what you need without, exposing yourself to the dangers of having a, general purpose language running.
Yeah, that's great. So we know, we kind of went over this earlier, but especially if someone jumped back in, if they want to compile it to WASM, which again, if they jump back in, they don't have to. That was an optional thing. Typically, you're going to be using Go and Rust. We also mentioned there's assembly script, which is a TypeScript-esque type thing. Do we know off the top of our heads if there's a Python version? I'm sure there is. I don't know.
There definitely is.
Yeah, so you can typically get to WASM in most languages that you're comfortable in, but that is not a requirement.
Yeah. So right now, if we look at kubectl and we get pods, we'll see that there are no pods. We can say yoke take off this cats and the main.wasm that we compiled. We can run that command, and when we run kubectl now, we can see that we've built and deployed those cat pods. We have deployment. We can, let's say, get deploy, and we have that.
High availability. We're not doing just 2, folks. We got 3 replicas because we care that much about the cats.
That's exactly right. Okay, but this was a very simple package, right? We basically just created one deployment, and that was that. There's no way, we could do a port forward to one of these pods, but there's no way to expose this right now. So let's change that. Let's see if I have any diff, no. Okay, let's add a service. So here I just checked out a new branch. And in this branch, the only difference is that we do have this create deployment. We can see that in our run, we are encoding to standard out that deployment that we created, but we're also going to create a service. Right, so we've added a second resource, right? And we're basically just writing a service, and we're returning this core v1 service, release a namespace with a spec, and we've built the spec here. We've built the service ports, we've built the service spec. It's great because you don't even need, this is what we're talking about YAML and documentation and discoverability. Here, if I wanted to say, here I'm using a type node port because I wanted to make it available to my host machine. But if I wanted to change this and figure out what I needed, I could say service type, cluster IP. I can
get the full description there. Yeah.
Means the service will only be accessible inside the cluster. Like I can figure out all of these things. If I want to go, navigate to these definitions, if I want to navigate to these definitions, I can go see them. You get such a great developer experience from code that you don't get from YAML.
I couldn't agree more. That is even when you have a a schema for static JSON, it's not this. It's much less pretty. It's much less integrated. And this is beautiful. And you could go a step further with this too, right? Not that you necessarily need to, but you could take that service that you have here, you could put that into a separate file that could be its own module, that could be administered by a different team, it could be by a different code owner, it could be an entirely different package that's published somewhere else and then imported here.
Exactly. That's
all fantastic.
Right. And so if we rerun the test run to just see what we're generating, you can see now that we still have that old deployment, but we also have that service. We have that element, the service, and we can see that it has this metadata. It has these values on the node port. The selector is for the application for cats, and it's of type node port. This 30,000 over here is just because I'm exposing the Docker, the kind cluster over 30,000. So I'm just matching with that. That was in the kind configuration that I did off camera. So if we create this, we can run takeoff again. We'll just find the correct command. I don't want to type. Okay, let's do it again. Then we can say yoke inspect, or we can stay in the theme and say black box.
Love it.
We can see that we have the release here for cats. We can look at cats. We can see that we have 2 revisions of it. There's a little bug here, but that's a demo. We expect to see a little bug. We can see that we have 2 revisions. The first revision only had 1 resource, and the second revision has 2 resources. You see that we built it from 2 different WASM files. It has 2 different SHAs and at 2 different times. And we can compare version 2 with version 1. And we can see that what we've added is a new, in the namespace default, core v1 service, cats. And here is the difference. So if we look at kubectl, we can get the pods. And now if everything works correctly, we should be able to access it over the node port. If I show you the kind setup, what we did is we created a port mapping between the container port inside of the node, which was 30,000, to our host port of 80. And we're listening on the local address. So if we go back now to the browser, and instead of going to localhost 3000, we just go to localhost. We're now serving from localhost directly into our Kubernetes cluster, the package that we deployed via Yoke, via that program.
Excellent. And what a great project. Yeah, David, thank you for sharing that. Super fantastic. I hope this really takes off. And I know you were saying earlier too, you don't even care if it takes off. You hope that it just kind of inspires changes in the community. I hope it takes off. I want your thing to go super well, and I hope that we can reach some folks with this. I also just love the whole theming you've done with elevating it to aerospace and everything like that. The theming is great. The concept is great. I think people are generally coming around on this idea with YAML, but it's a very slow burn on that. I'm not sure if that's just my bias speaking there, but I've definitely heard it.
I think there's a lot of inertia. I think what you described before around, the ease that there is about getting started with YAML is hard to get over, right? But I'm Montreal based, and I went to the Go meetup for Montreal, and I did a lightning talk on Yoke. And I asked the question about who liked Helm, who had a great experience writing Helm. And it was a very, very, very small minority of folks. So hopefully, different options will be considered in the future.
Well, I have a little bit of, anecdotal evidence. You've seen the SDK I've written, which not for Kubernetes or anything, but has a similar concept going on. And that's still growing to this day, and it hasn't been updated in over a year. So I think if we get some people behind this,
I'll stop sharing my screen for a second so I can look at your face.
That's right. Perfect. Fantastic. So, I think I've seen people take to this general, it's infrastructure as code, I don't know how often we said that word today, but just to clarify, it does fall under the umbrella of infrastructure as code. So it's not totally new in concept. But there is still, YAML is still the default go-to for so many different platforms, not just Helm, in general. And I think we see so often that it always outgrows what YAML really can support. And then we have examples like this where it's it doesn't have to be that way. It just doesn't have to be that way. So again, David, thank you for sharing that. Super, super great. Let me, I think we're going to wrap up the stream in a second, but I want to say first, we do have your link in the chat, and we'll have that in the show notes as well. Is there anything else you want to shout out while you're here? Any socials, any LinkedIn's, any things like that?
You can find me on Gopher Slack as David MDM.
There you go.
And that's about as social as I get. So, but I'm very kind. So, I'm social in that way, but I don't have many social handles. So David MDM on GitHub and also in Gopher Slack.
You are. You know what's I spend way too much time on Twitter, and people are always kind of there's a kind of a joke that goes around that says like, hey, all the real developers aren't on Twitter. They're, that's why you always see, on Twitter, it's always like beginner JavaScript stuff and whatever. And it's like, folks, there he is. I found him. He's over there. He's in the Gopher Slack. He's making really cool stuff. He's just not always tweeting. So I'm glad that I was able to grab you out of your dev environment and bring you back into the camera so we could show this with some people. I'm going to wrap it up. My name is Kyle, also known as Tech Squid TV. This whole thing has been sponsored by depot.dev. We build things in the cloud. Specifically, we're building Docker containers. We can also run your GitHub Actions in the cloud. We accelerate your builds. We have you spending less time building those things in the cloud. And hopefully soon you'll be building using Yoke as your package manager, using Depot as your Docker builder, and maybe we can we'll throw in one of our friends over at fly.io. You can deploy to them. All right, David, hang out with me, David. We're going to hang out for a second. I'm going to wrap up the stream. Thanks for hanging out, everyone, and we'll see you in the next one. Actually, real quick thing. We're actually going to have a stream tomorrow. I haven't put anything out yet, but if you happen to be here, you're hearing about it now. We'll have some info out on the socials tomorrow, but we're going to be here with one of the co-founders of Depot. His name's Jacob, and he works on a whole bunch of stuff with forking the BuildKit server and actually building a new optimized version. So we're going to learn a whole bunch of stuff about BuildKit. Once again, thank you, David. Thank you, everyone watching, and we'll see you next